Hey, welcome back to Stewart Science. This video is a little bit thrown together here at the last second, so if you hear my dog barking in the back, I apologize for that. I wanted to just give you a real quick overview of four little topics in the bigger idea of thermal energy. So we kind of talked about four little things in class, and so just kind of to recap those. The first thing we talked about was conductors versus insulators. And if I were making this video again, I would take a video of this. But what we did in class is that we took a piece of plastic which felt warm and a piece of aluminum which felt cold. And I put an ice cube on each one, and the aluminum melted that ice cube, even though it was colder, a lot faster, which was kind of messed up in our heads. Like you're thinking warm things would melt something faster. But aluminum is a conductor. So the first thing I wanted to talk about was conductors versus insulators. This is very simple. Conductors easily give and take thermal energy. Insulators trap or block the flow of that heat. So an insulator would be like a Yeti you have in the walls of your house to keep your house warm in the winter and to keep the heat out from your house in the summer. A conductor you use a lot with cooking because you want to give heat to your food. So a conductor allows thermal energy to flow. Think basically all metals do this. Insulators are like air or glass or styrofoam. Insulators block the flow of heat. The next thing we talked about were these particle diagrams behind me. And so we zoomed in on the molecules and we talked about how molecules are always moving. But in a solid, those molecules are locked in place, and so they're vibrating. I have like a little model that I showed us in class of vibrating particles locked in place. And the hotter it gets, the higher the temperature goes, the more those particles vibrate, which means the faster they move. Eventually, if they vibrate fast enough, they become a liquid because the particles break free of where they're locked in place and they're allowed to flow. Now, if you'll notice here, these particles are about the same distance. So when something goes from a solid to a liquid, it doesn't really change volume very much. So the spacing doesn't really increase until you get to a gas. A gas particles, once these particles gain even more speed, which you can kind of see here by these arrows, when they gain heat, they speed up. Eventually, they become moving so fast that they kind of zoom off into space. So the space between these gas particles is actually not drawn very well here. It's 1,000 times further apart. So if you had 1 milliliter or 2 milliliters, if you had 2 milliliters of water and you vaporized them, they would fill a 2-liter bottle. So that's a big difference in space. So from a solid to a liquid to a gas, solid to liquid doesn't really spread out. From liquid to a gas, the particles spread out a lot. Solids vibrating, liquids free, gas is also free. So the words I'm looking for here for solid, locked, vibrating, close. For liquid, free, slow, close. And for a gas, far apart, fast moving, high energy. The next thing we talked about was heat transfer. So we talked about conduction, convection, and radiation. Conduction, convection, and radiation. These are three ways that heat is given or taken by an object. Conduction just means surfaces that are touching in contact. So if you touch a hot pan, that would be conduction. Anything that's in contact, physical contact, is conduction. Convection, it happens when hot stuff rises. You probably heard the phrase heat rises. Not exactly correct, but not too far off. It's hot matter rises. When things get hotter, like we talked about, they spread out a little bit. The particles move a little bit faster. So heat makes things expand a little bit. When it does that, it's less dense, and so it rises. So we talked about how hot matter rises. You kind of experience this when you put your hand over a pot of boiling water. You can feel the warm air, the water vapor rising underneath your hand. Or if you open up your fridge, you might feel your toes get cold as that cold air moves downward and the hot air moves into the top part of the fridge to replace it. So that's convection. This also happens in the mantle of the earth. You probably talked about this in 8th grade with plate tectonics. You have these convection currents where hot matter in the mantle rises, gets to the crust, and cools down and then it goes around the outside. And then the last one's radiation. Radiation is just heat transfer through empty space. So think light. Think warming lights. If you have any pets that you use a heat lamp for, you can think about. I like to go to Chinese restaurants, so I eat egg rolls. Whenever I go to a Chinese restaurant, there's always a red light that's warming up my food. So anytime you use light to make something warm, that's radiation. So conduction is contact. Convection is matter moving. Radiation is heat transfer through empty space. And the last thing we talked about, I don't have a graphic for this. The last thing we talked about was heat transfer. When you heat something up, it can either be endothermic or exothermic. So melting, boiling, those are endothermic. Freezing and condensing are exothermic. Those words sound really big, but if we just break them down, endo means in and exo means out. Think exit. So exo means heat out. If you have to take heat out to make it happen, that's exothermic. If you have to put heat in to make it happen, it's endothermic. So the things you have to do to put heat in would be melting. If I have an ice cube, I have to put heat in to the ice cube to make it melt. Endothermic. If I have water and I want that water to boil, I have to add heat to it. So melting and boiling are endothermic, heat in. Which means that if I put an ice tray in my freezer that has water in it, and what the freezer does is take the heat out of that to turn that water into ice, that's exothermic. And the same thing happens going from a gas to a liquid, which is condensation. So endothermic, melting, boiling; exothermic, freezing, condensing. Conduction, contact; convection, matter moving; radiation, heat transfer through empty space. Conductors give and take heat easily. Insulators block the flow of heat, or they trap heat. And these particle diagrams, particles move more as they get hot, and they spread out more as they get hot. There's not a big size difference from a solid to a liquid. Those particles are about the same distance, just a freedom difference. But from a liquid to a gas, there's a big size difference. There's a big speed difference. Hope you learned something today. As always, this is Mr. Stewart. Keep learning no matter what.